Welcome to X Squared Radio. I'm your host, Brooks Agnew. This is a special for Sci-Spy TV on the Inner Earth Expedition. This is part one, the space-based evidence. You know, when I first got involved with the Hollow Earth Expedition, I contacted Stephen Curry, who was then leading the expedition in the spring of 2006. And I was pretty excited about it because a lot of evidence had been collected, had been thought about, had been written about, but most of it was personal testimony or introspection or intuition. And we really didn't have a lot of scientific evidence. So I thought, well, gee, wouldn't it be great to join an expedition, be part of something, and really make a good scientific exploration, one way or the other? Unfortunately, in the summer of 2006, Stephen Curry passed away. And so the expedition kind of came to an end. Later that fall, the board contacted me and said, would you like to lead the expedition? So I said, let me think about it for about a month. So I did. And I got back to them and said, okay, I'll lead it, but we're going to have to change things a little bit. Not for me, but for the integrity of the expedition. Instead of selling seats to a lot of rich tourists, we decided to put on a good scientific expedition using the scientific method. So we started to look at some of the evidence, and of course it was in several categories. This is the first of those categories, which is the space-based data. Now, I guess the first event that really took place that got not just single scientists like myself interested, but institutional scientists interested, was a photograph or an image of Earth that was taken from space. It looked a little like this. Instead of the aurora existing over one pole or the other, depending on whether it was winter or summer, we noticed that there were auroras over both poles at the same time. This was quite anomalous. It was not what we expected. Maybe a little bit of reflection, maybe a little bit of spillover as the solar wind or solar flares or energetic particles coming from the sun passed around the magnetosphere and maybe came in on both poles, but not to the extent that we were seeing it. It got everyone excited. And so JPL, Jet Propulsion Laboratories in Pasadena, California, decided to put together what's called the Themis program. This was a nose cone, and inside of the nose cone was situated 5 satellites. They accomplished a launch engine, put the nose cone on there in pretty short order, I might add, and launched the satellites out into orbit. When they got out into space, they assumed 5 different orbits. You can see them spread along here in this slide. Basically, we had 5 different orbits stacked from Earth going out into maybe several hundred miles into space. And what occurred when these satellites were going around Earth at different speeds is occasionally they would line up. When they would line up, they'd start up the program and try to run the satellites and take measurements to see where the energy was coming from that was responsible for the auroras over both poles at the same time. And what occurred while the experiment was running, so the paper goes, is a cosmic bullet. You can see this bright spot here in between satellites 3 and 4. And so what happened was, as the shock wave from this cosmic bullet went passing out into space and went toward Earth, it passed each satellite, was measured in sequence, and when it struck the Earth, there appeared the aurora. And so they issued their report that the auroras were caused by cosmic bullets. That was it. That was the report. One event. I wasn't buying it. Neither was anyone else. There was a lot more to be done. There were more explanations as to why these auroras were appearing independent of solar wind, independent of solar flares, independent of coronal mass ejections. They weren't necessarily coming from the sun. They were coming from some other source. We took other wavelengths of pictures of the Earth, as you can see in this. We took an infrared image of the Earth, and lo and behold, there was this IR energy not coming from the sun, but coming from Earth. Infrared energy was jetting out of the poles of the Earth. And Earth was not the only planet doing it. We also photographed the similar patterns of energy coming from Saturn. You can see this hexagonal shape on the pole of Saturn. We also noticed it on Venus. There's another image of the auroras on both poles of Saturn. Kind of interesting that the energy to excite the atoms in the upper atmosphere in our on our planets, the ionosphere. On other planets, it's just their atmosphere. As these electrons get excited to higher energy states, they fall back to lower energy states, and when they do, they emit a photon. And that's exactly what we're seeing in these auroras over both poles at the same time. It's clear that this energy is coming from inside the planet. When we think about this, it gives us a clear picture of this rotational energy that may be coming from inside the planet and exciting these electrons and these atoms in the upper atmosphere. This is really important to know because if the planet itself is hollow and it has a core on the inside that is spinning very quickly relative to the crust, then it is operating somewhat like a giant motor, more correctly, like a giant generator. And when it's generating this magnetic force, this magnetic flux, it is jetting out of the north and south poles, exciting the ions in the upper atmosphere and making them emit light. This is the space-based data for the Hollow Earth hypothesis. Now, what I'm going to do is continue this in part 2 when we go over the seismic evidence. These are nice, short, compact videos for you to enjoy. More about the North Pole Inner Earth Expedition. I'm your host, Brooks Agnew. This is X Squared Radio with the Potential of All Potentialities channel on SciSpy TV. Thanks for being with us. My name is Brooks Agnew. This is X Squared Radio with the Potential of All Potentialities channel on SciSpy TV. This is the Inner Earth Expedition Part 2, the seismic evidence. One of the things we had to do when considering whether Earth's or planets form as hollow spheres is to try to collect as much data as we could that's already out there to support the hypothesis that planets might form as hollow spheres. And as it turns out, there is some existing data out there. There's some new data, and we want to consider that here in this very short presentation. First is that in the ordinary textbooks that one might pick up on planetary core geology, this is how seismic data is collected. We see the earthquake pulse at the top of this diagram. Let's say in Malaysia or Japan or Chile, there might be some strong earthquake on one side of the planet. When that earthquake occurs, the vibrations go down through the sphere of the Earth and they appear at other seismic listening stations around the planet. In doing this, we collect this information based on the time that it takes for it to travel through the planet. We call these waves pressure waves or shear waves, and as we collect them, we kind of get a sort of CAT scan of the Earth. Well, as we all know, the old theory of planetary core geology is that we live on this molten ball in space, and somehow we exist on these nice, cool tectonic plates on the outside, like cornflakes floating in a bowl of milk. All that sounds wonderful. We've accepted that for hundreds of years as the way all planets form. We make exceptions for the magnetosphere around the Earth. We're going to cover that in the section 3 of this presentation. But for now, let's just talk about the seismic data. In order to make that data fit the current model that I just described to you, we have to create these kind of shadow zones because these vibrations do end up at listening stations and we don't really know how they arrive there. Another picture looks something like this. You can see the pulse happening there at the top of the diagram, and the vibrations going all the way through the planet and ending up at different listening stations. The problem with this model is kind of a religiosity of science, I guess, where we have an idea what our planet is formed like. Many PhDs and many planetary physicists have given their ideas on how planets form, and we can't really refute that old high priesthood of science. And so what we do is we make the new data fit the old theory, and that's exactly what you see here in these textbook diagrams. What has been done is we have reversed that way of thinking. In other words, we've used the same exact data, and what we've done is we've done it in reverse. Instead of picking up the data from the point of the earthquake, we pick up the data from where it appears at the other end. And then we follow the data back to the point of the quake. When we do this mathematically, this is what the model looks like. As you can see, there are no shadow zones in this model. This is the new planetary core geology. You can still see the point of earthquake at the top, but now you see a nice organized way that the vibrations go through the planet if you consider that the core or the center area of the planet is actually void. It's actually got a space with no mass in it other than something that won't transmit vibrations like an earthquake. It goes back to an idea, a hypothesis that maybe planets expand when they form out of these large accretion disks, or whether they form electronically or electrically out in the universe. They form as very fast spinning, dense pieces of matter. And as they spin very, very fast, sometimes they become unstable and they explode, and they go off into asteroid belts or free-floating chunks in space, which we do see a lot of that. Or sometimes they become lopsided and they spin off a piece of themselves, and now we have a moon. We already see an evidence of that in our own solar system with Venus and Mercury. Mercury is large enough that it formed its own orbit around the sun, but this is what we speculate may have happened anciently. But sometimes we kind of hit this Goldilocks zone where instead of the planet becoming unstable and exploding or lopsided and spinning off a piece of itself, it just simply expands and cools, expands and cools. And so this idea of expanding Earth hypothesis has been proposed. Over a period of about 4 billion years, the electrically formed planet spins and cools, and the crust then begins to separate from its center, and you end up with a hollow core. I'll explain what might be in the middle of that in a subsequent presentation. But let's just talk about expanding Earth. It doesn't take much of a observation to see that all of the tectonic plates that we see above the ocean or just below the ocean level on the Earth once fit together very neatly. As you can see in the bottom image here, all of the landmass on Earth all fits together. Australia, Antarctica, North America, South America, Africa, everything fits together nice and neat. As the planet expands, sort of like a balloon inflating, you can see the tectonic plates begin to separate, and they separate nicely into what we observe right now as the continents on this planet. Of course, as a scientist, we have to ask the question, if that's true, then there has to be evidence to support that there's not only an outer crust, but there must be an inner crust. And if the crust is as thick as we think it is, based on the mass of this Earth, based on the orbit around the sun, the distance from the sun, and the amount of time it takes us to go around the sun, then we must have a crust somewhere around 900 miles thick. And there's a tremendous amount of mass in that crust. And that amount of mass must have its own gravitational attraction, which means there must be some kind of formation, some kind of activity on the inside of the crust, gravitationally speaking, as there is on the outside of the crust. And that is the Harvard model. This is the Harvard University proposal that this might be what planet Earth really looks like. That we have this troposphere on the outside, which we enjoy and fly around in and can exist on the surface of, a thick and continuously undulating crust of 900 miles thick or so, and then a gap, and then an inner core spinning at a different, we believe, a higher velocity than the crust based on conservation of momentum. That makes a lot of sense. But if that was the case, I have to take this a step further and ask the question, there must be some evidence of some activity on the inside of this crust, gravitationally speaking. And lo and behold, Dr. Y. Sessions with Washington University commissioned his graduate students to go back through 600,000 of those seismograms. I showed you just one of them, and put them into a computer model to see if we could determine if there's an inner morphology. And this is what he quoted. We concluded, after 600,000 seismograms, that deep in the Earth's mantle, there is revealed the existence of an underground water reservoir, at least the volume of the Arctic Ocean. That's true. That is real, scientific, repeatable evidence, data, that shows that there is another ocean on the inside of the crust, at least as big as the Atlantic Ocean. How they determined that is they could sense the waves crashing on the shore on the inside of the planet. This is very, very compelling data. It presents an image of the Earth that may look something like this. This is one of the reasons why we decided to commission the greatest geological discovery in the history of the world, an expedition to the North Pole region to see if the crust is actually thin enough that we can determine an opening between the two oceans. It may not go all the way through like a hole, but it may be an opening in the crust where the two oceans blend. We intend to try to take an expedition to this area to see for ourselves. This is a short video for the Inner Earth expedition. Next time, we're going to do part 3, which is the actual sea-based evidence to support the Hollow Earth hypothesis. My name is Brooks Agnew. This is X Squared Radio on the Potential of All Potentialities channel of Sci-Spy TV. Thanks for being with us tonight. Welcome to the Hollow Earth Hypothesis, Part 3, Oceanographic Evidence. We've been following our series on the Hollow Earth. That's a good thing. What I want to start out with talking about is discoveries that were made in the ocean that might support the idea that there is an ocean underneath the crust and that there is a vent between the two oceans. This is what we're going to be searching for. This is the question we're going to be asking. One of those pieces of evidence, very simple to prove, was the discovery of an international team of scientists led by Graham Pearson, Canada Excellence Research Chair in Arctic Resources at the University of Alberta. And he has discovered the first ever sample of a mineral called ringwoodite. Analysis of the mineral shows it contains a significant amount of water, 1.5% of its weight, a finding that confirms scientific theories about vast volumes of water trapped 410 to 660 kilometers beneath the Earth's crust, between the upper and lower mantle. This was a remarkable discovery, even though you can see by the picture it's rather small. I'll blow it up for you. This rather unimpressive brown diamond almost was overlooked until it was identified, and what we realized is that this diamond came up through a volcanic vent, came from the inner crust, and contains a large amount of water, chemically speaking. That confirms that there is an ocean on the inside of the planet. So we wonder, what does this opening look like? Is it a tunnel that we can walk into and
reach the inner earth that way. There's a story out there called Edidorfa, which is simply Aphrodite spelled backwards. And it talks about a man who walked into Mammoth Cave and walked into the inner earth. So I went to Mammoth Cave. I talked to the people that run that cave. They've been there their entire lives. And what we discovered after speaking to them is that the deepest part of Mammoth Cave only goes down about 360 feet. That's a little short. If we did find an opening that you could walk into, in order to get through 900 miles of crust, you'd be walking well over 1,000 miles on foot in the darkness. There's no way one man could carry enough food and enough water and have a light burning long enough to reach the interior of the earth. So this story, Edidorfa, is just a story. So what are we talking about here? What kind of opening are we talking about? Look at this 1968 satellite composite. As you can see, this was done by the ESA-7 satellite. It clearly looks as though there's a hole there. But you have to understand how satellites take their images. They go around and around the Earth, and each time they go around the Earth, they take a strip of film. Over time, you get enough strips of film that it covers the entire northern hemisphere as far as the satellite can see. The stitch point, the stitch zone, is the round hole you see in this image, not really an opening into the inner Earth. We also have seen historical maps tend to look like there's some kind of opening up there, but when we fly over them, we take satellite pictures of them, we don't see such an opening. So what does this mythical interior planet look like? Is it lush and green? Does it have an inner sun? We're going to get into that in the next section. But this is what's driving people to think about this all the time. People have dreams about it. People have a high emotion about it. And we want to find the science behind this legend. Well, currently what we can document is that there are seafloor vents. These are areas where the interior heat and gas and energy that's in the inside of the Earth is coming up through the mantle, reaching the seafloor, and coming into the ocean. We still have that occurring today. One of the things that we do realize is that when we examine the age of the Earth, that is to say the mountain ranges like the Himalayas or the Appalachians or the Rocky Mountains, what we determine is that Earth is actually about 4.5 billion years old. But when we check the sea floor, we find something very much different. The oldest sea floor that we've been able to sample is only about 50 million years old. Well, what that tends to indicate to us is that somehow, when these continents were all together, the Earth aged. Then, as the Earth went through cataclysmic changes and those continents began to separate, the sea floor was left as giant cracked opening areas between the continents filled in with water. We don't know exactly where the water came from. It could have come from space, it could have come from inside the planet, but we do have an ocean that goes over most of our world on the outside, and now we know we have evidence there's an ocean on the inside of the planet. So what does this vent look like? Is it a small little crack like this, or is it something like this Earth vent model shows us? Is it something we could sail a ship into or fly an airplane into? We don't know. We have no evidence showing that this exists. But this is a model of something that's popular out there, and it certainly drives our imagination. We do see records on the sea floor. We see buildings and ruins and roads and all kinds of things that obviously used to be on the surface that are now many, many, many fathoms underneath the water, some over 6,000 feet under the water, like off the coast of Cuba. What caused these things to sink? Whole continents, it appears, have sunk beneath the sea. These could be cataclysmic changes in the shape of the crust. It could be cataclysmic amounts of water added to the surface of the planet. What we do have is a thermal record of these volcanic activities sitting on the seafloor. We can see these pretty readily. We also see records like this, ancient sea vents. Only these ancient sea vents aren't on Earth. They're on Mars. These could be openings into the interior ocean of Mars. Don't think that that's very outlandish, because we have evidence on Enceladus, a moon, that there is an ice crust because of the exposure to the absolute zero of space. But underneath that is a global ocean of liquid water. And occasionally that water comes up through the poles and jets out into space. Spectrographically, we know that this is water. That's not the only moon. Titan's moon also has evidence of an interior ocean. If these moons and Mars show evidence of interior oceans, why not Earth? We have a sample, a cross-section of seafloor vent in this picture that was taken off the bottom of the sea. So if there are these vents, if there is an inner ocean and an outer ocean, how do they mix? When do they mix? Well, an interesting phenomenon occurred in the year 2007. In the year 2007, it was very warm in the Arctic. It was very windy that summer. And the Arctic ice calved. That is to say, a big piece of ice broke off and floated out to sea. It opened the Northwest Passage for the first time in maybe recorded history, to where ships could sail in these waters. It was treacherous, but it could be sailed. These big pieces of ice floated off into the ocean, and eventually they melted. These pieces of ice were large enough they could have dwarfed the state of Rhode Island. So what happened the following year was the most remarkable thing, because every few years oceanographers go to Malaysia to sample rays, like stingrays and manta rays. And in 2008, the Malaysia ray study was conducted again. Normally, they see about 50 to 60 new species of rays, because the ocean is subjected to various stresses, not only from human presence, but also from the stresses the sun puts on it, and galactic forces as well. Rays are very sensitive to this, and they express this by mutating. Same as tree frogs in the rainforest. They do exactly the same thing. When there's pollution, when there's a dry season, a cold season, the frogs will mutate. They'll have extra arms, they'll change colors, their eyes will get larger. Different things will mutate in these rays. Normally 50 to 60 mutations are what they find. But in 2008, they found over 1,500. And these weren't mutations. These were new species. Brand new species, like this shark. Looks like an ordinary shark from this picture, but actually it is an ancient six-gilled shark. Not very common in surface waters. More examples of rays that are not mutations, entirely new species, fully developed. This is not the way nature works. Nature doesn't just introduce a new species out of clear water. It has to come from somewhere. Other species, giant manta rays, even this little fellow, obviously not made for our oceans, made for a dark ocean where maybe light isn't so prevalent. And this deep water octopus also showed up. These are not mutations. These are entirely new species that showed up. We also had the dorsal squid, which you see on the right-hand side, and then the infamous frilled shark. Oh, we have fossils of frilled sharks, but we've never seen a fully developed adult frilled shark swimming around. Obviously, this shark was there. It didn't live very long in our waters, but it came from somewhere. We believe that this vent opened up, and that these unusual species of rays and sharks and squids and octopus came up through that vent and ended up in our waters and ended up getting discovered. So what happens when two oceans mix? Well, this is a picture of where the Atlantic Ocean and the Pacific Ocean come together. Obviously, you can see they don't mix very well. The Atlantic is on the left, much saltier, a little warmer. The Pacific is on the right, less saltier, a little cooler. They don't readily mix. I mean, I'm sure they do over time, but this is where they mix. We would expect oceans of different areas of the Earth to do exactly the same thing. And our thermal images of oceans show exactly that. Not all oceans are alike. They differ in salinity and temperature and crystallinity, oxygen content, CO2 content, methane content. We expect the inner ocean to be just like that. What we want to do is we want to go and see the sea. We want to take a ship up to the Arctic, and we want to examine these things with scientific instruments. We want to check this ocean, where the oceans come together at this opening. If there is an opening, what we need to ask, and what everyone asks, is how are we going to get there? Are we going to take a jet airplane and fly over it and snap pictures out a little porthole? Not very likely, not at 17,000 feet. Are we going to sail a boat up there? Not possible. These are the roughest oceans on the planet, and typically, even in the summertime, they're covered with a thin layer of ice. So the Russians have built a nuclear-powered icebreaker, a brand new one called the Arctica. We're not talking about Soviet-era ships here. This is a brand new ice-rated hull ship, almost 500 feet long, 80,000 horsepower, a 3.5-year fuel supply, and able to carry 125 passengers. Scientists from all over the world will bring their instruments and their crews, and we're going to search for this opening, this mighty ship that's able to travel, the only ship in the world able to travel this sea. We're going to be looking for the oceanic depression. This is an area where sea level is not necessarily sea level. You see, in ancient times, when ships used to sail together from the old world to the new world, they kept maritime records. Every single day they wrote in the log, the night shift, the day shift, because they needed that information to hand along to travelers that would follow in their wake. Well, occasionally, as the record goes, one ship would just simply disappear, several hours, even a day at a time, and then it would rise up magically out of the sea and join them again. Now, keep in mind that the way these ships stayed in touch was usually by the crow's nest. You'd crawl up in the crow's nest, you could see a few extra miles over the horizon. But these ships could not be located. They just kept sailing by sextant in the same direction. And then it would reappear. They recorded it as a place where sea level is not sea level, where the ocean dips down. So I interviewed a rear admiral about this, a retired rear admiral, and I asked him about the oceanic depression. He was familiar with them. And I asked him what he thought would cause them. He said, well, we think it's caused by areas of Earth where the gravity is not the same as everywhere. It's more intense, and it pulls the water down deeper or closer to the crust than the surrounding waters. And I thought about that for a minute in light of our project that we're thinking of now. And I said, maybe you would consider something else. Maybe this is an area where gravity is actually lower than it is elsewhere on the planet, a place where the crust is thinner, and that the surrounding gravity actually pulled the water away from that area, leaving the depression. He thought for a moment and said, you might have something there. So this is what we're searching for. 10,000 square miles we will survey in 15 days to try to find this oceanic depression. We don't know what's on the bottom. We don't know if there'll be ancient buildings on the bottom, if there'll be ships on the bottom, if there'll be a huge opening on the bottom. We don't know. What we want to do is go and see. My ancestor, Sir James Ross, in 1831 discovered the North Magnetic Pole. His first venture, not successful. His ship was caught in the ice and crushed. His crew and all of their gear offloaded onto the ice. They made it through the winter, and they were rescued early in the spring. And then they tried it again. this time he was successful. And in 1831, he discovered the North Magnetic Pole. What we intend to do is leave out of Murmansk, Russia. Oh, I wanted to show you this little gull that he discovered, named after him, the Ross gull. As you can see, this gull is not built for Arctic weather. It doesn't have a thick layer of blubber on it. It's not made for 60 or 70 degrees below zero. And yet, this Ross gull sails north for the winter to nest. The world's leading ornithologist has no idea where this gull goes in the winter to this day. This gull has to go somewhere where the warm wind blows to nest in the winter. What we want to do is leave out of Murmansk, Russia. We want to sail toward this area above the 86th parallel on the Arctica, and we want to discover this oceanic depression, and we want to sample the water when we get there. This will be known as the North Pole Inner Earth Expedition, and you can always keep up with everything we're doing as we announce it on X Squared Radio. I'm your host, Brooks Agnew. Thank you for joining us on this segment. Don't miss Part 4. Welcome to the Hollow Earth Hypothesis, Part 4, Core Physics, the Evidence. We're going to talk this section about Earth's magnetosphere. What causes it? What changes has it been going through? What new measurements have we made about it? And how is it really so unique in our solar system and maybe even in the universe? The magnetosphere is kind of a protective magnetic envelope that surrounds the Earth and protects us from high-speed, high-charged particles that approach our planet. Protects us against radiation from the sun and from other sources. You can see it depicted here in this graphic. So let's get into it. We have a lot of information to cover. When we talk about the quest to discover Earth's planetary core physics, this is the big question. We used to think that we lived on this molten ball traveling through space, and somehow we existed on these cool tectonic plates on the surface like cornflakes floating in a bowl of milk. Believe it or not, this is basically how all geology textbooks depicted our planet exists in space. Now we're getting more evidence. Now we're beginning to see from space and also from Earth measurements a little different story. So what we're going to go into now is some official and very leading edge planetary core physics on how the planet is structured, at least as much as we know today. So when we talk about what is the core composition, this was a very, very big question. We thought that it was a molten ball of rock for a long time. But in the early 2000s and the mid-2000s, on up to 2010, we began to take spectrographic measurements of frequencies put off by the core of the Earth. And what we're going to reveal to you today is evidence that proves that that is not the case. We do not have a giant molten ball of rock as the core of the Earth. We may not even have a molten inner core inside the crust, rubbing against the inside of the surface upon which we live. What we know about this, we'll start with the Carnegie science. And this is a quote. Our findings suggest that as the core was extracted from the mantle never fully mixed. This is surprising because core formation happened in the immediate wake of large impacts from other early solar system objects that Earth experienced during its growth, similar to the giant impact event that later formed our moon. Before now, it was widely thought that these were very energetic impacts. They would have completely stirred the mantle, mixing all of its components into a uniform state. We kind of depicted it like this, that Earth may have collided with some larger body. In other words, what we tried to explain with this planetary core physics, because of evidence we've gained not only from the Earth but from other planets in our own solar system, is that two worlds merged or they collided in space. There are two aspects that we're going to consider here. The first is that these two planets were similar in size, maybe of different makeups. One very high vibrational and one very low vibrational, one very high frequency, low frequency. They came together not as similar bodies, but as dissimilar bodies, so that they didn't destroy each other, they more merged together. The reality is that the mass that makes up our planet Earth is not very dense at all. In fact, a neutrino, which is a tiny little, very fast particle traveling through space, sort of like its own galactic wind, neutrinos could pass through a light year of Earth and not hit anything. That's how much space there is inside the molecular mass that makes up our planet. So it would not take much to imagine a slightly different dimensional world merging with our world in this solar system. The second aspect is that perhaps one was very much smaller than the other. Maybe a quarter our size, or a third our size, or a tenth our size, but maybe very dense in mass, and so it punctured through the crust and became part of the inner core. Now, this isn't so outlandish because in our own solar system, we have a planet that matches this description right now. We didn't know this several years ago. We only knew this recently, even though we sent the probes a long time ago to the planet Uranus. We studied that planet for decades, and it takes a long time for a probe to go around a gas giant that size. But what we have discovered is that inside of Uranus is another planet. There's another planet on the inside of Uranus, orbiting or turning at a different speed. We wanted to study this because we knew that the way Uranus revolves on its axis relative to the other planets in our solar system is all wrong. Something was definitely different about this planet. And when we sent our probe and we discovered, this is what we found. It had an impact with another planet, and that planet is still on the inside of Uranus. So if it can happen to that planet, why couldn't it happen to Earth? This is just a theory that's out there. So the question we want to ask is, what if two worlds of different energies merged to occupy the same space at the same time? I call that the union of the polarity. My co-author E.J. Clark and I wrote 4 books on this called The Arc of Millions of Years. It's 2,000 pages of nonfiction work studying 44 ancient cultures and matching it up with modern physics, modern geology, and modern cosmology to explain those ancient traditions. This is what we came up with, what we call the union of the polarity. It is very carefully explained in those books, and it's fictionally explained in the Birth trilogy. So the union of the polarity would have been a rare event in the universe, to be sure. It wouldn't have been cataclysmic in the sense that both planets were destroyed. It wouldn't have knocked it out of the solar system. It would be an event of beauty and of resonance. And this is what we propose with a possibility of the hollow Earth hypothesis. So this great magnetosphere that we have is formed because we have 2 counter-rotating bodies, one on the inside and one on the outside. The outside one is a 900-mile thick crust full of iron and rock and all kinds of gases, and it's undulating. That is to say, it's stretching and squeezing because the moon is going around us and we're going around the sun and we're revolving on our axis. All of these gravitational fields have an effect on the integrity of this crust, so it is moving all the time. And as it moves, It generates a lot of heat, a lot of movement, a lot of magma moving around in it. We're talking about 900 miles of thick, dense matter. Then a gap. We don't know how big this gap is. We suspect it's somewhere around 1,000 miles. And then a very hard, solid, single metal core. I'm going to explain that to you in a minute. But the core would be rotating on its axis at a very high, a relatively high RPM, that is to say rounds per minute or rounds per day. The crust itself takes roughly 24 hours to make its revolution. So the crust is moving slower, the core is moving faster, and that counter-rotation creates this tremendous magnetic field around the planet, which you see depicted in this graphic. When we break this apart and we try to look at it, this is what we think it looks like. This is the most common modern cosmological model of what the Earth looks like right now. We have the tropospheric surface upon which we live, the green and lush surface with water, not very thick at all. And then we have this crust I explained to you that was depicted in the bright orange body here, 900 miles thick. Then we have an unknown area. We don't really know much about it. We can't tell much about it by frequency. We can't tell much about it by seismic information. We don't believe that it is very dense because otherwise it would be dragging the core to a stop or into the same revolutions as the crust itself. So the theory is that this area is actually open space, that it's actually air, or it's actually, hot gases. And then the bright ball in the middle. Now this is what we are beginning to know the most about. We're beginning to measure it. We measure its frequency that it puts off coming up through the crust. What we know now is the answer to this question. What is the composition of the core? This is the question we've been talking about for upwards of 8 years, and now we have some very, very good data to share with you in this section. We don't really know what the composition of this space is. Let's just not talk about that tonight. It could be molten rock. We don't think so. It could be open air. Many people and many ancient cultures believe that is the case. So we know from Arizona State University reports that they have detected continent-sized blobs of semi-liquid magma inside the crust. And the estimates are the crust is about 900 miles thick. Now, these continent-sized blobs are, as I said, semi-liquid. They're molten, but they're more like glass. Glass is a liquid, but it just moves very, very slowly. If you look at old windows, for instance, you can see that the silica in the glass is flowing from the top of the window pane to the bottom of the window pane, and it kind of makes it wavy. That's because it is flowing. It's just flowing very, very slowly, kind of like a glacier. That's what these blobs are like in the inside of the Earth. Then we have received spectrographic information. On the left side of your screen here, you will see a typical absorbance curve. This is where we have noticed that energy is being absorbed at specific wavelengths that are consistent with iron. You can see in the right side of this picture here a solid iron crystal. The small red dots that you see in here are xenon. Most of the xenon in the Earth, or of the Earth, is locked in the core, in this iron crystal matrix. We know this because we can measure this spectrographically. It's been measured in numerous occasions, numerous different labs, and these absorbance peaks are very, very sharp, very repeatable, and very identifying for iron. But it is a specific state of iron. Iron, as you know, can assume a lot of states. It can be rust, it can be ground state iron. It has 3 different oxidation states. And we know the frequencies that these different oxidation states put off, and we know the frequency that's being put off by an iron crystal. The issue is that this iron crystal has to be under a lot of pressure, and it has to be under very high temperature, about 6,000 degrees C, which is the same temperature as the surface of the sun. That's pretty hot. It's also not really duplicatable in any ordinary sense. So what they have done is they created an experiment. This is called the diamond anvil. It was created a long time ago, but now it's being applied by Carnegie Science, by Cambridge, and by other universities around the world. Typically what this is two large industrial-sized diamonds, very hard. And then what they do is they put an anvil in between these, a crucible of sorts. And then they push these together at very high pressure, creating or duplicating the pressure that would exist at the center of the Earth on a very small point. And then they shoot a laser through the diamond to heat the crucible up to 6,000 degrees C. And then they measure the frequency that's being put off by this iron crystal. And lo and behold, it is exactly the same as what is being put off by the core of the Earth. This is an example of the crucible that's placed in between the diamond rams that are pressed in on it. You can see it's not very large. It's got a very small area where a small amount of iron is placed, and then it's pressed into crystalline form. This is another image of the same thing. And what was formed now is not just a black ball. What is formed is a crystal form of iron that looks something like this. This is what the Earth's core is made of. You can see, this is obviously outside the crucible, it's a close-up picture of it, but this is what the core of the Earth is made of. Now it's at about 5.3 grams per cubic centimeter. This means it's more dense than almost any matter on Earth. It's also at 6,000 degrees C. So this is way up in temperature, same temperature as the sun. And what kind of light would it put off? Just like this. This is an iron filament lamp. It puts off a frequency that has a wavelength between 446 and 520 nanometers. That's 1/1000th of a meter. So it is a light that can be used to cause photosynthesis, because photosynthesis is best at 450 nanometers, obviously very close to the middle of this frequency band that's put off by the iron. So if temperatures are suitable, that anything organic wouldn't be immediately combusted like is on our fire tonight, it would grow just like plants on Earth. What would they look like? We don't know. But if photosynthesis will be sustained, then so will also other forms of life. One of the other things that we notice about the magnetosphere is that it wobbles. For many millennia, the solid core and the massive crust of the Earth were well aligned, straight up and down. But there are unstable forces between them that must be considered. Any two bodies that are rotating together have a gyroscopic property about them. And these two bodies have different rotational speeds, which are creating this magnetosphere. Of late, the wobble in the alignment of the North Magnetic Pole has been rather pronounced. The North Magnetic Pole normally moves by a force which is called the Coriolis effect. The Coriolis effect is an effect whereby a mass moving in a rotating system experiences a force acting perpendicular to the direction of motion and to the axis of the rotation. You could take a bicycle wheel and you could spin it very fast, and you could try to turn that bicycle wheel flatways, and it will resist that movement. That is the Coriolis effect. It is a force perpendicular to that rotational force. We're seeing this not in one, but in two bodies. And now those two forces are beginning to work against one another, and so they're beginning to wobble. Now, what does this mean for us? In recent rapid movement, the North Pole could be exhibiting the behavior of the beginning of a pole reversal. The sun goes through this about 11 years. Every 11 years, the north and south poles of the sun switch. Is it cataclysmic for the sun? No, not really. Would it be cataclysmic for the Earth? We believe so on several different levels. First of all of the animals that use magnetic fields of the Earth for navigation would have to recalibrate if that could be done. The way we navigate our own aircraft, our own map systems, our own systems of knowing which way is north, which way is south, east and west on our planet is changing. Of late, we've had to sandblast the numbers off of runways and change them because the north magnetic pole is changing the compasses of the aircraft. So we could be getting ready for a pole shift. We don't really know how fast these pole shifts occur or how frequently they occur. We know that Earth, somewhere around 100 to 120,000 years ago, the North Pole was the South Pole, and vice versa. We don't know if this takes 1 year, 7 years, or 700 years to occur, but we know that it's fairly quick because we have a record in the igneous rock. Igneous rock is formed when molten rock freezes. When it freezes, it assumes the magnetic alignment of the Earth at that time. We have a vignette of these alignments in igneous rock around the planet, so we know that the poles were shifted at one time or another. All this is evidence, and we cover this in the fictional story Birth, Two Earths, One Race for Time. It is now a trilogy. It's 1,100 pages, and it is a story that walks you through this cataclysmic joining and re-separating of the two worlds. We don't know if the planets are getting ready to separate or not. We don't know if they're getting ready to change poles. But if you want to read a great story about it, you can find it on Amazon. BirthTrilogy.com will also lead you to the same place. So, this is the story of the construction of the Earth. We know that this magnetosphere exists. We know what causes it. We have observed it in other planets. Mars, for instance, doesn't have a magnetosphere. It could be because Mars does not have a core. It could be because Mars' core is rotating at the same speed as Mars's crust. If that was the case, no magnetic field would be generated. Without protection, the surface of Mars is subjected to the shortwave or high-frequency radiation that comes from the sun, effectively sterilizing its surface. The same exact thing would happen to Earth if our magnetosphere were to disappear. Our atmosphere over the last few decades has been shrinking, especially during solar cycle 24. Why? Earth itself makes its own atmosphere, of course. We have respiration that goes on the planet, we have combustion that goes on the planet, and various gases change in slightly between their partial pressures on our planet, but the atmosphere is also added to by solar ejections, coronal mass ejections, and also the solar wind and particles that come from the sun to the Earth excite and then join our upper ionosphere and make our atmosphere larger. Because the sun has been so quiet, we haven't been getting that feed of particles and material from the sun like we normally do. So our atmosphere has begun to shrink. This has had some effects which we already are seeing the results of. Number one, our satellites in orbit are lasting longer, up to 10 years longer. Why? Because they're no longer dragging against the upper atmosphere, slowing down, having their orbits decay and falling to Earth. Those satellites haven't had to be replaced because they're not running into the atmosphere. They're still orbiting in free space without running into anything. The second effect is we're losing our insulative blanket around the planet. That means that the Earth itself can radiate more of its energy back out into space. We call this albedo. That's the amount of energy we receive from the sun that is reflected back out into space. Without our insulative blanket, Earth is going to begin losing its energy to space, which means Earth is going to begin cooling, not warming, cooling. We could be headed for an ice age if the sun doesn't pick up its activity in the next 5 to 10 years. By the way, ice ages do not approach slowly. They approach quickly. 1 or 2 winters is all it takes for an ice age to get started. All it takes is for snow to fall on the snow from the previous year. When that happens, infrared radiation that would normally be absorbed into the ground, warming the ground up, is reflected back out into space. Without the ground warming up, the Earth will rapidly cool. If this occurs, we could be looking at the farm belt in North America moving south by as much as 300 miles. 300 miles to the south. These are effects that we know about. Mathematically, they are not only probable, they are very possible. And I think that these are things we need to be aware of. This is why I think people are becoming more sensitive to the idea of hollow earth theory. It is not so much a journey to the center of the earth as it is understanding the cosmology and the planetary core geology of what makes up planet Earth. I'm Brooks Agnew. This is the Potential of All Potentialities channel on Sci-Spy TV. Thank you for joining us.